Alrighty, and then finally we have example 2. So we have an 8-foot ladder leaned against a wall, and the height of the ladder along the wall is given by h of x, where x is the distance along the floor from the base of the ladder to the wall. So to me, before we even go on, I'm going to draw myself a picture. So we've got our nice ladder leaned up against the wall. We're going to hope and pray that our building is structurally sound. It makes a right angle with the ground. And we know that the ladder is 8 feet long, and they are telling me that I've got the height of the wall and that the distance x is the distance from the floor of the ladder up to the base of the building. So that horizontal distance along the ground would be x. So the height of the wall, if we remember that a squared plus b squared equals c squared, then we've got the base would be x squared plus our wall squared equals our ladder squared, 8 squared. Then we can go ahead and solve for that height along the wall. When we do, we find that we'll get the square root of 64 minus x squared, right? And then we square root it to figure out what that height along the wall is. So that's where we come up with our function. That makes sense to us. So then we are asked to find the horizontal distance along from the base of the wall to the base of the ladder. So basically find x when we want to reach 7 feet up the wall. So that means that we're going to replace h of x with 7. So we've got 7 equals the square root of 64 minus x squared. And then to solve for x, we would start by squaring both sides. So 49 equals 64 minus x squared. Subtract 64 from both sides. Negative 15 equals negative x squared, or positive x squared equals positive 15. Now as I solve for both sides, well, how do I undo squaring something? I square root both sides. Now remember, technically we would take the plus or minus square root, but since we're dealing with distance from the base of the building to the top of the ladder, distance is always going to be positive. So we would approximate that using our calculator. We get about 3.873-ish feet up the wall. So as we are going through and we're solving radical functions today, know that we can model a lot of real world situations using radical functions. So keep that in mind.